next week I will provide quite a long list of videos, probably mostly coming from one or two kind of YouTube channels. Some of them provide very good kind of videos to explain things like this relay, how it works. Because I can't really make a very good animation with very kind of limited time. So I'll recommend some of the videos for certain topics and you can watch. It's hard for me to explain with some text and pictures. If you watch the animation, things become very clear. Is everybody still here, or you guys tired? I'm very tired. I don't. It's very different from face-to-face interaction. I feel like I'm yelling at a computer very loudly and getting tired quicker. All right, let's get back to here. So this is another kind of figure with the relay, but this one we have, let's see, explain a little bit more. So it's got single pole, single throw. Okay? So single pole means the movement part. It's only one armature. There's only one of them moving. Sometimes you attach another one, they have double pole. Single throw means it's only connect to one circuit. That's only one circuit here. There's only one circuit here. Will the tutor be recorded? Yeah, so I'll record these 3 hours, but I'll probably break that into 3 parts. I'll try to load on the website. But again, if you guys feel tired, you can take a break with your own pace. Or best way is you guys just talk to me, because I feel like less kind of stressed or less tiring if I'm talking to somebody instead of staring at my computer. But anyhow, so pole means how many movement part the relay has. Throw means how many circuit it's going to close. So if you look at this one, you can get the idea. This is a single pole, double throw. So single pole means this is only one armature is moving. However, you can look at the armature now is when it's activated, it goes to move down. This is activated. It's going to connect this circuit. It's going to connect this circuit. Once it's not activated, it's going to go up. It's connected to another circuit. So it means it's actually connecting 2 different circuits. So we have a single throw or double throw. Means for the single throw, it connects 1 circuit. For double throw, you connect 2 circuits. You won't have more than double throw. For the pole, this is only 1 single pole, but you can have a single pole, 2 pole, 3 pole. Probably 3 pole is the limit. Normally we have single or double. Okay. There's a normally open and normally closed terminal. So normally is we consider when this coil is not activated. That means our control doesn't do anything when this armature is in its free position. That's called normally. So this one is normally closed circuit. I'll draw it in a different color. So normally closed is this circuit. When the armature is not doing anything, that's normally closed. and this is your equipment that connects to your whatever your device is. Okay. Then, if the armature is on, then it goes connect to this circuit. This common part is your device as well. So it's getting another connection. So by switching this input power on and off, you kind of connect your device to kind of two different circuits. So some of the machines you need to do that to provide kind of two different kind of circuits on and off. So in that situation, you use double throw because it saves a little bit logic. If you use a single throw, you have to use two different single pole, single throw switch or relay to achieve the same function. This is just more compact and easier to achieve. Okay. But we can't possibly join all these figures every time when we do the electrical design. So there will be electrical circuits and control circuits. There's two different ways in engineering we do to kind of show people your design. This control symbol or control circuits normally is drawn to show the concept, show the logic, show the ideas. The electrical circuit is drawing to show the physical connections. You can see for this one, this is the single pole double throw relay contact. If you draw it in electrical circuit, you will have coil. So that's your control terminal. Normally you can control to a switch or something to control your input. And A is the identifier. So A means this relay is A and this two is the same component. And these are the kind of your output connector to connect to another circuit. And this is another circuit for your output to achieve certain task. And that's your pole, which is basically a switch. And if you turn this on and off, the pole will go up and down, connect to different circuits. So this is electrical drawing. And because this is probably a little bit still too complicated, then we go for the control drawing. This is also quite important. If you go to a factory or workshop, you get a new machine or new kind of workshop. What you have, your people will give you a bunch of drawing. Shows how everything's connected, and then those drawing might be a control drawing. So things are all complicated, like you don't draw the coil and things physically like that, like electrical components. You become just a C is for coil. So that's the representation for the coil. And A is also the identifier. So you see there's A here, means this is a single component. So this coil is controlling this switch. And this symbol is basically the switch, okay, the switch. With a bar in there means it's normally closed. So it's drawn at its condition when there's not activated. And this one is called normally open. Okay, so it's like a capacitor, but this is not electrical circuit. It's a control circuit. So this is actually a switch. So both of this is a switch or input, we'll call it control. And this is a coil. We're going to control this to switch with a coil with no current. This is connected. You can consider this is just a closed loop. When there's no coil current, this will be open. So this will be open circuit. But when there's current going through the coil, then this normally closed one will be open. Then this one will be open. Then the bottom one will be closed. So this is just a simpler way to express the design of your system. So although I don't formally teach this, after a few examples, you probably get to know how to actually draw these control diagrams. So this is a more control diagram and the electrical diagram for a little bit more complicated relay. So top one is a single pole, single throw. This is the simplest one. You got coil A. This is a normally open, because you can see that shows it's normally open. When there's no control signal, this is an open circuit. Okay, so that's the electrical drawing. Electrical drawing too complicated. So the main thing we have to learn is draw something like that. Then you will realize the PLC program is coming from this kind of drawing. It's not much more complicated than this. It's very similar. This one is more complicated. 2-pole double throw. So electrical circuits have one coil. You got A1, A2. This means you don't have just one pole. You have like another pole. So this is one pole. This is another pole. When the coil is activated, both poles are physically connected and move together. But each pole is going to connect completely different circuits. This is one circuit. This is another one. The control drawing is quite kind of similar, just more components in there. You have a coil A, then there's A1. So this is one of the poles. So the pole 1. This is a pole 2. But you link that this is all from A. That's all controlled from A. If you have another coil, it will be B and C or different things. And this is normally closed, then normally open. So this one has a 2-pole and double throw. Sometimes it's just 2P, 2D, just 2-pole, 2-throw instead of single and double. This is a just more complicated case. You got 3 poles, double throw. So electrical symbol is more intuitive. You get a coil, B, you get 3 poles, pole 1, pole 2, pole 3. So 3 switches. And it's single, it's double throw, sorry, it's double throw. So you connect, each one of these connect 2 circuits. It's normally open situation, you connect one circuit. It's closed situation, connect to another circuit. And this is the electrical drawing. So this is a normally closed condition. This is its open condition. Just connect to a different one. So this single relay can control 6 different circuits. With this 3 will be the same logic because you connect to the same relay. The same logic will turn this 3 on and turn these other 3 off. So it's hard to understand all this without example. So let's look at an example, a practical example, and how do we design this using relay logic, and then look at how do we achieve this using a PLC. Then you got an idea of why we're getting a PLC. So this is a simple relay control system. You have a pump to get rid of the water. You have a valve to add more water. There's water in, water out. What else do we have? I think that's it, right? Yeah, so you have, basically you have 2 switches to turn the valve on, turn the pump on or off, pretty much. So the logic here is pump can be only operate when the input valve is open. So you can only kind of turn on the pump when there's input goes in. And the input can be open when the pump is either operating or not. So basically input can be on anytime. All right, so basically you can switch this on and off with a switch. And this one, you can only switch this pump on when the valve is already on. Okay, so let's see how complicated we need to actually achieve something like that. So for the valve, So basically you have two switches. For the valve, you turn it on, off directly. This is a control relay A. Let me see that. So that's your first switch, S1. So this is your control circuit. Control circuit. And this is this is your electrical circuit. No, that's not control. This is your electrical circuit. This is your control drawing. And your PLC program were very similar to this control drawing. So look at the electrical circuit. You get a switch to turn the relay on and off. Then the relay will connect to the valve. So switch on, relay get energized. Your valve is on. Okay, so the water is going inside. Then for this pump, because we want to have this pump on only when the valve is already on, which means you need to have S1 and S2, the two switch, both pressed to be able to turn the pump on. So we kind of have this circuit connected. Look at this circuit. This has two switches. This is S2, which you need to press to turn the pump on. And this one switch is controlled by S1. So unless S1 is already pressed and the valve is on, the motor cannot be on, even you press the motor start. So logically, it's all connect like that. And in the PLC program, in the relay logic program, it becomes like 3 levels of logic. First level is you have your S1, control the pump. No, sorry. You have S1, control the valve. That's this logic for the first one. The second one is this same switch. See that's the relay. So this is the same relay output. Is connect to the output. So this is basically just connect to the output. Right? So this is your input from the relay. The second line, I have to draw another color. So this first line is that part, input of your relay. The second part line is that part. That's the output of that relay. And the third part here, this third line is basically this middle one. You have a relay and another switch, S2. So you can see this A1 and A2 is coming from the same relay. You just have 2 different poles. That's why we need this relay is a it's a double pole, single throw relay, right? It's a single throw because it's only close a circuit or open a circuit. It doesn't control 2 circuits, control 1 circuit. So it's single throw. It's a double pole because you have to kind of having 2 moving poles to connect 2 completely different circuit at the situation. So it's relay A is double 2 pole single throw relay. Right? And then this bottom one is how it's physically connected. So just for this simple control, you need 1 relay to do this and 2 switches. That's quite straightforward. Okay? If we're going to use a PLC to do that, so this is your control drawing. This is a PLC program. You can see very, very similar, right? Each line is corresponding to each line of your PLC program. Okay? And this input 1 is connected to your switch 1. Input 2 is connected to the switch 2 from the outside. So your PLC sits in the middle, and left side is the input. The input module connects to the switches, and this is your memory input because you're physically to the switch. So the status of this I1, I2 is the same as your switch condition. Then you connect your output for the solenoid valve and for the pump to the output terminal. Right? But if you look at the logic program, it's very, very similar, okay, almost the same. Then this output module will physically connect to the solenoid and the pump contactor. So basically another type of relay, but handling high current, and connect to the power supply. So in this case, the PLC, because it's kind of a big chunk stuff in middle, it doesn't save too much. You still need to have some relay contactor to control. So it doesn't help too much. But when the control has become complicated, then it will show the advantages. So this is another comparison. You can see the similarity between relay ladder logic control diagram with a PLC program. This is just a Allen Bradley PLC program. They are quite similar. Okay. Let me see. We already mentioned this. So we need a two-pole single throw. This is our this thing. Oh, sorry. How do I erase this thing? Anyhow. Give me a minute. Erase pen. So this is our relay. These three things together is that two-pole single throw relay. And this thing physically in our PLC, we don't need it. It becomes the logic inside the sorry, it's hard to erase this. So it becomes just this switch. Okay. This O1 is basically the same thing. That's correct. So this three things, you can see both, they all have this I1 and this 0, 1, and this is connected. So this basically represent that relay, but using the kind of PLC program. Then this is not physically there. This is just a memory. A memory bits, when it's equal to 1 means it's connected. When it's equal to 0, it's not connected. Instead of physically have some relay moving around. So the advantage of relay over PLC, so from that program, you probably don't see it, but once you have like hundreds of different kind of control ideas and you have to connect them together, you will see for the PLC, what you do is you just have a bit more modules with more IOs connected to all the different more device. The logic is implemented in the program, so you don't have those complicated wiring connections. For the relay logic, you have to actually do the wiring, because you have a double pole single throw relay, and that will give you 6 different wiring you need to connection. So this is a typical control box for your relay logic. And turns to PLC, all this kind of wiring, this cabling, these things are become a program inside the PLC. We still need a little bit wiring. Okay, so there's still wiring that cannot be kind of eliminated, but this wiring is mainly for the input output. The logic is not achieved through this complete wiring. So if you open a control box for any machine workshop, you will see something more like this compared to that. So more people is using the PLC. Compared with PLC with a normal PC, you can see there's no kind of absolute distinction between these two in the application point of view. For the simpler situation, people is more using the PLC. That's more PLC for the simpler, smaller system, because PC, the cost, like the starting cost is quite high. But then when the performance of system getting extremely complicated, then you do PC, because PC can handle many more complex calculations, and even if you need image processing and things like that, then PLC is not powerful enough to handle that. And also PLC is easier to implement. The PLC program is more or less kind of generalized. Like all the different company, they have very similar programming language. When you get to PC, the problems like the programming language and software become so many different types, and most of them take long time to learn. So the developing time will be higher, and also maintenance and fix those times will be longer. So, but in some situation, like in many of those situations, you can choose either a PC or PLC to achieve your task. So for PLC, the I/O modules and other external connections, you can pick from the PLC modules. For the PC, you probably need to get additional hardwares like I/O modules for PC. For example, you can get a National Instrument I/O card or other I/O card to connect to your PC, and use the I/O card to talk to the equipment. Now we have like another example, like we have like two pumps wanted to be controlled through relay logic and PLC. Right, so let's have a look at this one. So the question is, if our tank control problem we just mentioned had a second pump, and that used to drain the tank. So there's a solenoid valve putting water in, and there's another second pump to pump it out. And this second pump is with quite complicated logic. So it needs to be on only when the valve is on, and needs to be on only when the pump 1 is on. So pump 1 is adding water to the tank, and pump 2 is draining the tank. So if there's no water going in, you are not allowed to drain it. And also the pump 2 can only be on when there's a switch to control it. Okay, so from the previous design, the design in the last few slides, so from here to this new question. So basically we're adding a new pump. We have a new switch, but how do we reconnect the wires and get the same logic? Because this pump 2, so that's what we have for the previous one. This is a previous question. This is a new question. So ideally it's easy, right? You just need to add a new switch. This is to control the pump 2. But because pump 2 can be only switched while the pump 1 and the valve is on, so your existing relays for pump 1 used to be single pole, single throw. It doesn't work anymore because you need to have another pole to connect the pump 2. So the original S2 needs to become single pole, 2-pole single throw, because it needs to close the pump 1 and also close pump 2. And your original relay for the valve is double pole single throw. Now, because it not only needs to connect the valve itself, also it needs to connect the pump 1 and pump 2. So it goes from 2-pole single throw to 3-pole single throw. Because of adding this thing, you need to have A3 and another, where's that? S2, okay, that's another, the relay needs to have another pole. So both relays need to have another pole. So if you can design this, then you have to replace both relays you already have for the valve and for the pump 1. And also you have to get a new relay to get pump 2. So you pretty much have to disconnect all the wires. If you see this, you pretty much have to disconnect all the wires and replace the parts and get new wires in. But if we just using a PLC, what's extra stuff we need to change? From the PLC point of view, the logic is the same. You have another pump, and you add a switch. Sorry, this is a switch S3. So from PLC point of view, your input will have another switch S3 connect to it. And inside your PLC, what's happening is you add one more line of your logic. The beauty of PLC is all these stuff. These stuff is a memory bit. It's a software. You don't have to connect any wires. You connect this external switch to the PLC. Then those relays, single pole, double pole, 3 pole, you can do 100 poles if you like to, because you just create another image of the same memory, it becomes another pole. So you don't need to replace those relays with more poles. Rather, you just add another line of the program with the same address, then your problem is solved. Okay, so it saves a lot of rewiring and reprogramming time. It's very straightforward, and that makes the PLC much more appealing compared to the relay logic. That's why the industry completely replace those relay logic with PLC, because it's flexibility, it's easy to make changes. I've put those Siemens and also Allen Bradley manuals on the website. I think this is the last slide. Then you can go have a look. There are a lot of good videos, like I said. So next week, I'm going to provide some links for those videos, and you can watch those videos. If for some of the concept, if I kind of didn't explain very clearly, or if I forget to provide more information on that, you can go for those videos, or you can just read some other articles online. And I guess this is it for this week. So this week is a bit shorter. It's only 2.5 hours. Next week and the next few weeks will be kind of full on. I think most likely we won't be able to finish everything in 3 hours, because this first week normally I will run 2 hours, but I got like 30 minutes more. Because like this online delivery just make things a bit slower than usual. So that's it for this week's lecture. If you have any question, can you just ask now? I do have consulting time from Wednesday from 9:30 to 11:30. You can send me an email to book a time to ask me questions. But I think we've got enough communication time through the lecture and tutorial. We've got 3 hours every week. You can also ask me here, just right now. Another way of communication is go to the Moodle website. There's discussion forums. If I show the... You can go to the Moodle website. If you just go to the student discussion here, you can post some of your questions over here. Then I'm checking this every day, so I'll be able to provide you some answers if there's more common questions. Okay, thank you for coming for the lecture. If we don't have any questions, we will finish up here. Okay, I'll see you guys next week.
Well, thank you, Stephen.
Thank you.
Thank you.
Cheers.
Thank you.